This is the first problem that I have. And so here we have 242 divided by 6. And so I took that with I was not aware of this being called the scaffolding model or the scaffolding strategy. Um, I actually was known it to be the big seven. So anyways, I have our 6 and going into our 242 here to figure out what 6, I kind of knew 6 times 4, but just to give me that definite here, I did 6 times 4 and adding a 0 for the hundreds. So that would make go into 40 times and it would make 240 and we would subtract that giving us 2. So our answer is 40 with a remainder of 2. Here is block model. Um, so I have the 240 and 2. Um, six goes into 200. Here I showed my work for that. So I knew 3 times 6 is 100 or 18. So then 30 times 6 is 180. And then I was like, well, that's about 20, till 200. So then I was like, well, 3 times 6 is 18. And those added together gives us 198. So I took that difference and that difference is 2. So we carry that 2 over to join our 40, making it 42. 6 goes into 42 7 times. So, and 6 times 7 is 42. So we have a remainder of 0 here. And if we look at 2, 6 doesn't go into 2. So 2 is actually going to be our remainder. If we take our answers here and combine them, 33 plus 7 equals 40 with a remainder of 2. Here's my next problem of 684 divided by 6. Here I did that scaffolding or our partial quotient again, big 7, whatever you'd like to call it. So this one was rather, simple. So here I know that 6 goes into 600 100 times. So here I have that. And 6 times 100 is 600. So we subtract and we are left with 84. I know that 6 goes into 84 at least 6 times. So, well, 6 goes into 84 at least 10 times here. So, I take that away from 84, giving us a 24. And here you can see 6 goes into 24 4 times. So 6 times 24 is 24. And so we are left without a remainder for this problem. Taking our products here and getting our quotient here. This one I did do different from my first example. I don't have their complete place values here with it being 600 or an 80. I just have it in the spots that they would be in normally. I really like this idea. It's great. So 6 goes into 6 one time. That is 6 times 6 gives us 6. Subtract. We are left with nothing. We still carry just so that we are consistent. So we look at 8. 6 goes into 8 one time. So we take 6 times 1 is 6. Take away 6 from 8 gives us 2. So this 2 goes over. And it's not just 2, right? Here we're talking about tens. So if we're carrying 2 over, it's actually going to be 2 tens. So we have to take that over knowing in our heads that we're converting it and unbundling that to gives us 20. So we add 20 to our 4, giving us 24. 6 goes into 24 4 times, giving us no remainder. So here is our total with hundreds, tens, and our ones. Here's my third problem of 428 divided by 8. Again, here is my partial quotient, big 7. Um, I know that 8, 8 times 100 is 800. So I just went here and I just did half. So I was like, oh, well, half would be 50. So 50 times 8 gives us 400. We subtract that from 428, leaving us with 28. Then I know in my head, and some kids won't. So what we could do is, 8 plus 8 is 16. And then, oh, well, I think, I'm not sure if maybe I could go higher. So then, oh, then they could count in their hand, add 8, see where they would end up. So here, um, we know that 8 goes into 28 3 times, and that gives us 24. So we subtract that from 28, leaving us with 4 as a remainder. So our total is 50 plus 3 equals 53 with a remainder of 4. Here is my block model. Here I went back again to using the place value. Here's 400, here's 20, and here is the 8. So here I did 8 goes into 400 50 times. And you can make that a little easier by looking at 40. 8 goes into 40 5 times, so then add that extra 0 in. So we take away 400 from 400, leaving us with 0. We carry that just to be consistent. With 20, we look at 8. How many times is 8 going to 20? 2. And that could be used from our back here, 2. 2 times, so that gives us 16. So we take away 16 from 20, leaving us with 4. Here we are talking, this 4 is a ones. And that is because there's the 2 place values here to signify tens instead of just the digit. So here we just carry just the 4, and we're going to add that to our 8 to give us 12. So then we look at 12, and how many times 8 goes into 12 is 1 here. So then 12 take away 8 equals 4, which is our remainder. If we took these again, 50 plus 2 plus 1, 53, with a remainder of 4. This is my fourth and final project that I chose. I chose 724 divided by 7. So I love all the sevens. We'll just go with, I got my big 7 for the partial quotient. So 7 goes into 700 100 times. So 7 times 100 is 700. Subtracting that from 724 leaves us with 24. And 7 goes into 24 3 times, which is a product of 21. So if we take 21 away from 24, we are left with a remainder of 3. Taking our 2 numbers here, adding those together to get our final answer, which is 103, remainder 3. Here, I broke it down again just to its digits, not its place value. Both ways I love, this one gave me a kind of a chance to unbundle some stuff again. So here, we'll just start. 7 goes into 7 one time, representing that 100 here. So we have 7 take away 7 is 0, carrying the 0. So here we have 2, it looks like, right? But what this is the tens. We have to remember tens. And so remembering that it's the tens, this is not just a 2. This is 2 tens, which gives us 20. So really, I could have went, 7 goes into 20, so many times here, but I decided to carry that 20 over and unbundle it with my 4. So here I'm left with 24. So we're looking at 24. How many times does 7 go into 24? Well, that's 3 times. So we take 21 away from 24, and it leaves us with a remainder of 3 again. And we have 103 singles. That gives us 103 with a remainder of 3. Love it. I'm loving this little pen thing here, you guys. Okay, here we go. Last and final example. So this is the 3,131 divided by 3. And so I took that with the big 7 here. So here I have the 3,000 131 divided by 3. And so I used the big 7 method here. And I know that 3 goes into 3,000 1,000 times. So 3 times 1,000 is 3,000. Subtracting that from our 3,131 gives us a remainder of 131. So in my head, I know that 3 times 4 is 12. So 3 times 40 would be 120. So we take 120 away from 131, leaving us with 11. Now 3 goes into 11 3 times, which gives us 9, and we subtract that from 11, giving us a remainder of 2. At first, I had thought like, oh, if you add 2 to it, oh, here, instead of just this 1, it would make the problem even. And I actually did go through the problem and I was like, oh, that's not right. So if you add 1 to that remainder, that gives us another whole 1. And so that is why that's how that would work. So we could either subtract 2 from the original number, or we could add 1 to give us that whole or to take away that whole. So here I showed if we did add just the 1, 3,132 divided by 3, and again that we have that 3,000 here, subtracted gives us 132. If we have, oh, and I didn't even finish my, geez. And then what? 3 goes into 132 40 times, which gives us that 120. So we take that away from 132, leaving us with 12. 3 goes into 12 4 times. Take 12, take away 12 equals 0. So that would give us our answer. I did write my number wrong here. Right here, this should be a 3, not a 2. Thank you guys for listening.